All right, guys, gonna do function notation today. I'm gonna have you turn these four problems in. This table right here is gonna be for numbers 1 and 2, and then 3 and 4 you just need to write out the function rule so it looks something like this. And I'm gonna do some examples in here for you guys. So if we have a table of data with our x's and our y's, and then it tells me f of x plus 2 minus 1. So what this is doing is that all of my x's are getting 2 added to it. So I'm just going to add 2 to all of these guys. So negative 2 plus 2, 0 plus 2, 2 plus 2, and 4 plus 2. All of my y's, because the function really means y, all of my y's I'm subtracting 1 from them. So 3 minus 1, 7 minus 1, 9 minus 1, 11 minus 1. So this is the solution to that guy right there. I'm going to do another function rule, but I'm going to use this same table. So I'm going to use that same table a couple of times. This function rule is going to be 2f 3x minus 1 plus 6. Okay, so this is happening to my x's. So that means if it makes it a little bit easier for you guys, I'm going to write it as point notation. So that becomes 3x minus 1. And the y, I'm going to actually write it over here. Ran out of room. So the x is going to become 3x minus 1. Whatever is happening here, that's what your x is becoming. And then this is times, and this is plus to your y. 2y plus 6. So if that helps you out, you can do it that way. And I'm going to go through the process. So for my x's, I'm going to do 3 times negative 2, negative 6, minus 1, negative 7. 3 times 0 is 0, minus 1, negative 1. 3 times 2 is 6, minus 1 is 5. 3 times 4 is 12, minus 1 is 11. The y's I'm getting multiplied by 2, and then I'm adding 6. So 3 times 2 is 6, plus 6 is 12. 7 times 2 is 14, plus 6 is 20. 9 times 2 is 18, plus 6 is 24. 11 times 2 is 22, plus 6 is 28. So that's it, really. That's what we're doing here with these guys. We're going to do a whole bunch of examples like this. So I'm actually going to do the first problem that was on your paper right here so that you can make sure that you know how to do it. So this is our rule, and this is our table that we're using. So to the x's, all I'm doing is adding 1. So all the x's are going to get plus 1. So that's going to be negative 1 and 0 and 1 and 2 and 3. All of the y's are getting times 2 and then plus 3. So this times 2 is 6, plus 3 is 9. This times 2 is 10, plus 3 is 13. This times 2 is 14, plus 3 is 17. This times 2 is 18, plus 3 is 21. And this times 2 is 22, plus 3 is 25. So that's the answer for number 1 on here. Now what it'll also do is it'll tell me something. It'll say the domain is twice as big. So that means I'm doing 2 times the domain, which is x, and 1 unit to the right. So if I'm moving it to the right, I'm adding something to it. So if I'm moving it 1 unit to the right, I'm going plus 1. It's always going to be f and then that whatever is happening to your domain. If it tells me the range is 3 times as big, I'm going to go 3 times the f and move down 2 units. Down means I'm going to subtract, and the 2 units is that. So let's say that it tells me range is 7 times as big, and up 10. Domain is half as big, and left 5. Okay, so I'm going to start with the domain. Domain is half as big, which means it's going to be 1/2 times the x. And left 5. So to move left, I have to subtract. So I'm going to go -5. The f always goes here. The range is 7 times as big, so I go 7 times that. And up 10, so I'm going to add 10. And that's really it. That's all that we're doing here, okay? So fairly simple. Do one of the questions from the assignment. So I'll do number 3. Function is twice as big, so the function, which is f, is twice as big with the domain